Hello, students. Welcome to the Unit 5 test review on similarity. I want to apologize. My last video I made, it looks like it didn't have sound. I'm not sure why. A little bit of a learning curve here, but I'm going to go through this as quickly as possible. Feel free to fast forward, pause, rewind, whatever you need to do. I'm not going to be in class on Friday the 11th, so I'm going to post this video hopefully tonight. So that you get you can get a head start, and also so that you can have a resource for when I'm not there. Okay, so let's go through this as quickly as possible. Given that triangle ABC is similar to triangle DEF, which of the following statements are true? Choose all that apply. What we know is that all angles are congruent and all sides are proportional. Do not confuse yourself. Sides cannot be congruent. So for instance, E in E right here, BC is congruent to EF. They go in the same order, that's great, but they can't be congruent. They're only proportional sides. So E can't be one of the solutions. Here you also see the AB over DE, this one right here, AB over DE, AB over DE is equal to DF over AC. Well, it goes in the same order, but the issue is that it goes from the left-hand triangle to the right-hand triangle, and then back, and then it starts again on the right, and then goes back to the left. You can't go in that order. You have to go left to right, left to right. So that one, although it's matched up nicely, doesn't work. Angle C congruent to angle D, nope, first and last are not going to work out. So that's why B is not an option. So let's talk about why the rest of these are options. AB, we have AB in ratio with DE as AC is in ratio with DF. It goes left to right, left to right. The right order is also there, so that works. The second one that works is C. Angle B congruent to angle E. Yep, in order, works out well. Angles are congruent while sides are proportional for similarity. The last one, EFBC. So EFBC, that order is great, and DE and AB. So I go from right to left, and it all works out well. Nice. Going on to number 2. Given a couple pieces of information, knowing that my angles are congruent, I'm going to fill in the missing pieces. The first thing I did was I labeled G as 50 degrees because it said so right here, but I also labeled K that because they're both congruent if they are similar triangles. H came along and that was 60, so I labeled L 60 as well because they are congruent. The last one, I had to solve for the rest. So you see my algebra here. I take away from 180, 50, and 60 because I know each triangle has those angle measures, and I get 70. So I know angle J is 70, measure of angle J is 70, which is the last one, and so does angle N. That also has to be 70. So I put those in for my angle measures. K I substituted in, I wrote in, and L I wrote in as well based on the original. So that's where everything came from for my angle measures. For proportional sides, you have a couple options. When I go from H to J and I go L to N, you can either go GJ and KN, which I have here, or you can go GH and KL. It's really open-ended here. You could have written either one of those. As long as the order is consistent and you go from left to right or right to left in the same order of what was given. Same thing for F, KN and GJ. It could be KL and GH or LN and HJ. Again, going right to left for this particular example. Okay. Number 3. Mary is making a scale drawing of a bedroom. Her rectangle room is 12 feet wide. I wrote that down. Or 12 feet wide and 15 feet long. On a scale drawing, the width of her room is 5 inches wide. What is the length of it? I don't know. But what I do know is I can set this up a few different ways. I can compare 12 to 15 and 5 to x, or 12 to 5 and 15 to x, which you notice is what I actually did right there. Notice I'm going from feet, inches, as long as it stays feet and inches and feet, I know my result will be in inches. So I don't really have to convert anything if I don't want to. I just have to know that my result will be in inches. Find my cross products, solve, and I get that it has to be 6.25 inches. It did want everything to be in inches. Oops. I'm sorry. I went too many times backwards. Okay, so 6.25. An apartment building is 90 feet tall. This has to be in feet. It's 55 feet wide. If the scale model is 11 inches, okay, so I have 90 feet tall. Whoops. I have 90 feet tall and 55 feet wide. I don't know how tall the model is, but I know it's 11 inches wide. That's fine. I'm going to solve this. I'm going to solve it for inches, but then I need to convert it to feet afterwards because that's how the answer is given, is in feet. So, find my cross products and solve. I get 18 inches. I then have to divide that by 12 and find out that it's 1.5 feet tall. Okay, number 5. Are the following triangles similar? If so, explain how and identify the parts of congruent angles and the corresponding sides. Then write a triangle similarity statement. Well, okay, I'm given all 3 sides. I'm also given 2 angles. I could prove this any way I want to, by angle, angle, side, or by side, side, side. I would rather do angle, angle because I don't have to do any algebraic proportions, but that's totally up to you. You can do it by side, side, or side, angle, side. Knowing that this is similar by angle, angle, I already have it given. Done. I list out the angles that are congruent. That's enough to prove it by angle, angle. I can make that statement because I have at least 2 of them. Knowing that, I then had to write out my congruent angles and my corresponding sides, which I wrote over here. That's how my sides correspond. And then it wants me to write a triangle similarity statement. Okay, that's my triangle similarity statement. All the parts are there. In number 6, same thing happens. Again, I'm given so much information, I don't know what to do with it, other than the fact that I should probably just say, oh, by angle, angle, they are similar. Here are my angles. Here are my proportional sides. One thing that can help you when you go to write your triangle similarity statement, just go in order JLM, JLM, SPN, SPN. So you might as well just use the work you've already done to just write your triangle similarity statement. Okay, number 7. Using a little algebra, I was given 43 and 90. I was given 47 and 90. So I in purple and in orange, I did the algebra out, and it comes out to be 47 and 43. So it's the missing values. We now know that by angle, angle, these are similar. We have angle A is congruent to angle D, angle C is congruent to angle F. We know B and E are congruent. I could say that as well. So they are similar by angle, angle. I'll just add that one in. I don't have to. I'll just leave it the way it is. That's enough information. Number 8, find the length of the model car to the nearest centimeter. Well, this is given in meters. This is given in meters. This is given in centimeters and centimeters. So when I set up my proportion, I know that everything is given in meters for the top car and centimeters for the bottom car. So my result will be in centimeters when I solve for my x. Find your cross product, set it up, find your cross products and solve, and you get 18 centimeters. Again, I'm comparing the length 5 to x as 1.8 is to 6.3. All right. Oh, it wants me to round to near a centimeter, so that involves rounding 17.5 to 18. Okay, verify that the two triangles are similar. Well, in this case, I'm not given two angles. I'm giving one pair of angles right here. So when I'm going down my options, I'm like, okay, angle, angle, side, similarity, or side, side, side. I'm not given two angles. I'm also not given three sets of sides. That leaves me with one option. I'm going to have to go down the path of side, angle, side. So I write out my sides right there, and I prove that they are proportional. Awesome. I also mentioned my angle that is congruent. I have to use three letters because there's four angle x's right here, right? So I use my three letters T, X, U, goes in order, and V, X, W. And I make my triangle similarity statement the same, and note that it's by side, angle, side. Number 10, explain why ABE and ACD are similar. Then find angle C. Well, if you separate these, they both share angle A. Look at that. If I pull those apart, they both share angle A. I don't need to pull them apart. I'm just going to say angle A is congruent to angle A. I also know that angle B, or EBA, is congruent to angle DCA. So, by angle, angle, they're similar. Collectively, they add up to 12, and we have 5 and x to compare to. So 9 is to the whole thing of 12 as 5 is to x. It's the whole bottom part of this triangle compared to the whole side of this one, and then the whole length of this one compared to the whole length of this one. And let me just clean up. And I get 6.66, which works out well, repeated. Be careful that we don't compare, especially right now, you know the side splitter theorem by now. That's when the sides are split. 5 has to be here, and x has to be there for you to use side splitter. It would be 9 to 3 and 5 to x because that's the sides that would be split. But that's not where they are, so you can't use side splitter. Just be cautious. Okay. We have number 11. Students are asked whether the two triangles below are similar. Ed says the two triangles are not similar because he does not have any information about the angles. Jessica says that there is enough information. Who is correct and why? Well, you don't need angles. You can use your three sides. So 2 is to 3, as 3 is to 4.5, as 3 is to 4.5. Right? Well, we know 3 and 4.5 are going to work out fine, so that's easy. But does a 2 and 3 match up? Well, 2 and 3, 3 and 4.5, and 3 and 4.5 are all 0.66 repeated. They're all 2/3. So Jessica is correct. The sides are similar by side, side, side. In number 12, we are given two triangles. Again, we cannot use side splitter. We have to go in order. Well, we know that this side right here, this angle, sorry, corresponds to that angle, so they're congruent because the lines are parallel. This one is congruent to this one because they're corresponding angles. We also know that angle A is congruent to angle A because the reflexive property, It's both angle A in both triangles. So we set 3 is to x as 7.5 is to, 3 is to 7.5 as x is to x plus 6. So it's whole side, base, and base. So we, whoops, I don't know what I undid. Okay, that should be good. When we have this, we find the cross products, we solve, and we need the distributive property, and we get x is 4. And so we get x is 4. So when we know x is 4, we put 4 in. 4BE equals x, and we get 4. We put in 4 in for CD. So we have 4 plus 6, which is 10, so CD equals 10. I have those evaluated. I have angle A and it's congruent to angle A because the reflexive property, I've listed everything here. This should be quite an easy problem when it's all said and done with all nice numbers. All right. Ben places a mirror on the ground, so we have reflection. So what we do know is that 2.4 meters is congruent to, is proportional to 4 as 1.8 is to x. So I set that up. I did 2.4 is to 4 as 1.8 is to x. And everything's in meters, so your result will be in meters. Find your cross products and solve, and you get 3 meters. So it's a 3 to 4 ratio within the triangle, but from triangle to triangle, the similarity ratio, it's 2.4 to 4 and 1.8 to 3. 6, 12, 18, 24, 30. It's a 3 to 5 ratio, actually, from the right triangle to the left triangle. Okay, so number 14, a wall with height of 4 feet casts a shadow 6 feet tall on the ground. What is the height of the tree that casts a shadow which is 24 feet long at the same time? Well, we're going to set up 6 is to 24. Well, let's go large to small. So h is to 4 as 24 is to 6. Set those up. You solve for h, you get 16 feet. That makes sense. 6 times 4 is 24, so it's 4 times the size, which would make it 4 times the size of the wall, 16 feet tall. All right, find US and RS. You can use side splitter because of parallel sides, and you have them cut into parts. So the parallel sides are what is cut, the sides are split. Cross product solve. When you solve for x, you get 5.6. So US has to be 5.6, but then RS is going to be 5.6 plus your 14 original, and you'll get 19.6. Number 16, side splitter again. Cross product solve, you get 7.5. So PN is going to have to be 7.5, and LN, whoops, I lost my AirPod. Hold on. Okay. Hopefully you still have sound. Yep, so hopefully you have sound and it didn't go away. So 7.5 for this one, and then we're going to add 3, and that will give you 10.5. Okay, we have number 17. This one's interesting. You're given a bunch of portions. So 4.5 is to 2.6 is to 4.1, as 4.9 is to x is to y. I created an x and a y just to put variables there that I could solve for. But set up both proportions. It doesn't really matter. So I did 4.6 is to 4.5 is to 2.6 as 4.9 is to x. And I solved and got about 2.8 for x, meaning that LM would have to be about 2.8. I also used the numbers that I knew, 4.5 and 4.1. I set that equal to 4.9 and y, or in this case mn, and I get about 4.5 after rounding. So I know that that one is solved using the same numbers above, 4.5 and 4.1. Not that 4.1 was used, but we're using numbers that we already know, not ones we solved for. Okay, number 18. Here you're going to set it up as x minus 2 is to x plus 5. Oh, looks like I set it up differently. Okay, well, it doesn't matter. It's going to be the same thing, right? X minus 2 over x plus 5 as 32 is to 40. 32 is to 40. Okay. Find your cross products. You're still going to get 40 times x minus 2 and 32 times x plus 5. Again, it doesn't matter how you set it up as long as you don't compare x minus 2 to 40, you can't do that. That won't work out. Solving, we get x is 30, substitute 30 in. We get PS is going to be 28 and RS is going to be 35. 28 and 35. Good. Number 19, we're getting to the end here. This is the last page. So remember, it's like we have three triangles. So quickly, it's like if I were to take this triangle right here, I want to map it out. This is strange because I'm going to take this triangle and I'm going to copy it. I'm going to paste it right here, and I'm going to enlarge and turn. And what you notice is that it is also congruent. I'm sorry, it's also proportional. Awesome. And then I'm going to take that one and I'm going to paste it. And it's tough here. I can't rotate because it's a reflection. I can't reflect it. I don't think I can flip this around. Style. Nope. I can't flip it. But imagine that I put it right here, but it's going the other way. So you see it's really three proportional triangles. Too bad I can't flip that. Yep, I don't think I can. So I'll just delete it. But we know that 9 is to x as x is to 16 as the smaller side, let's call it b is to c, right? So all of our sides line up, but then we can also deal with the hypotenuses of them, right? So that was smaller to medium, smaller to medium, smaller to medium. Well, what am I given? I'm given really the hypotenuse in the whole thing. Oh no, I can solve just for what I have here. I can set up 9 is to x as x is to 16. And I get 9 because I did 25 minus 16, which left me with 9. So setting that up, that's your geometric mean. Find your cross products. You get x squared equals 144. You should know the square root of 144 is 12, plus or minus 12. Whenever we have an equation, a little hint here, a little math fact, equations allow for two results, both a positive and negative result for square roots. Find the square root, you get plus or minus 12, but it can only be a positive value because it is a distance, so x has to be 12. Do the same thing for this one. In this case, we are given short side and hypotenuse compared to the big triangle that has a short side and a hypotenuse. So short is to hypotenuse as short is to hypotenuse from the smallest to largest sides. And we get x is 25. Notice it's the same triangle as above, pretty much, right? Yeah. 9, we got 16, we got 15, we got 25. They're all the same numbers. If I wrote in the 16, it would work. Last one. We are given, okay, so what are we given here? We are given hypotenuse and short side in the big triangle. So we now have to use the hypotenuse and the short side in the small triangle. So 9 is to 15 as 15 is to 9 plus x. It's a quantity of them added together. So solve that and we get x is 16. Again, the same type of triangle as above. We know that that's going to be 16. It's all set up exactly the way we want it to be. And these are all the three of them are the same kind of problem. Okay. Hopefully that helps you. It's a little bit shorter, hopefully, than the last video. So, yep, and hopefully this one has sound because this is the second time I'm making it. Everyone have a great night, and I will see you on Tuesday the 11th, 12th, 13th, 14th, 15th, I believe. All right, that's your test day. All right, take care, everyone.